Hi guys, this is video 3-5, so see your checklist for when you should aim to watch this. And this is again on implicit differentiation. We've been covering this for the last 3 lessons, and this is what we've been working up to. So you want to use implicit differentiation. Implicit differentiation is when you do chain rule on everything. And you use it when you want dy dx, which is another way of saying y prime. Okay, so this is the same as y prime, or the derivative of y. So you use it when you want that and y is not solved for. So you've got variables, all the variables are just like mixed together. The variable that you want the derivative of is not solved for. And this is when you use implicit differentiation. You just do chain rule on everything. So we've got this, and when you do chain rule on everything, you don't jump right to doing the derivative. First you set it up with d dx, like the d over d, whatever your independent variable is. And then, so I'll just show you how to do it. So we've got 3 terms. We've got this single term on the left side of the equal sign, and then we've got these 2 terms on the right side. So I'm gonna go like this first. So I'm getting ready to do the derivative of every single term. So I haven't changed anything except I put a d dx in front of that, equals d dx 3x to the third plus d dx of 1, and I didn't even give directions. Okay, the directions are to find dy dx. So that's the derivative of y with respect to x. And if y were solved for, we could just take the derivative like we've been normally doing, but since it's not, we've got to do this. Okay, now we need to do chain rule on all of these. And okay, and let me show you something first. Okay, never mind. All right, so this here, so we've got to do the chain rule here, no matter what, whether this was implicit or not, because we've got 2x to the second y to the third is inside of sine. So I'll go in, out. And sometimes the more I explain these things, the more confusing it is. So just focus on what I'm doing if what I'm saying is confusing you. And then, so sine of blank is the outside function. Now to do the derivative of this inside part, that's a product, so I need product rule. And now don't write this down, but at this point we've got 3 ways of thinking of the product rule. It's when you got 2 functions multiplied by each other, so it's f prime g plus f g prime. Or if you're ever stuck on product rule, I've often encouraged you to just set it up like this. Leave blank brackets for f and g, so you'd have bracket prime times bracket plus bracket bracket prime, and then you just plug the stuff in. But now here's another way that we're going to be using whenever we're doing implicit differentiation, which is when the x's and y's are mixed together. Sometimes the variables are not x's and y's, but it's when all the variables are mixed together and you just want the derivative of one of them. And so this is how we'll set it up. Instead of bracket prime, you have d dx of a blank times blank, that's the bracket without the prime, plus bracket without the prime, and then bracket with the prime is d dx of blank. Okay, so that's how I'm going to set this up. And I'm doing the product rule on this one here. So it's going to be d dx of the, let me just do this. Some of you probably see like how to do it like without setting up blanks first, but I'll do the blanks just in case it makes it more clear for someone. And I'm going to do a big bracket around that because this is the derivative of the inside function, or it's going to be, and it's going to be multiplied by the derivative of the outside function. So 2x squared goes in there, y to the third, 2x squared y to the third. And then this is going to be multiplied by the derivative of sine, which is cosine. And then this parenthesis is the same as that parenthesis. Like we took the derivative of the outside function, but the parenthesis is really the same thing, and what used to be in there has to go back in. So 2x squared y to the third has to go back in. Now I've only taken the derivative of the outside function so far. Now I've got to go through where I see a d dx, I've got to do those derivatives. And I've got to do chain rule when I do the derivatives. So when you're doing implicit differentiation, usually when we do chain rule, we go derivative of the outside, or inside times derivative of the outside. But multiplication is commutative. You could do it in any order. So we're going to do the derivative of the outside function, which is 2x squared. So that derivative is just 4x times the derivative, the inside function when you're doing implicit differentiation is just the variable. So the derivative of x is dx dx. And then you just bring down the y to the third. Plus, bring down the 2x squared. Now, d dx of y to the third. So the derivative of the outside function, y to the third, is 3y squared times the derivative of the inside is dy dx. Okay, with implicit differentiation, the inside function is just the variable, really. Okay, so now we've taken the derivative, then this comes down, cosine 2x squared y to the third. Okay, now, guys, that was only this. Okay, so that part turned into that when we took the derivative. I've still got to bring down this equal sign. Okay, the derivative of this one, so the derivative of 3x to the third is 9x squared times the derivative of x, which is dx dx, plus the derivative of a constant is just 0. You don't even have to write that. Okay, now, after you've taken the derivative of everything, you've done implicit differentiation / chain rule on everything, then you go through, and if you see like a dx over dx, that's just a 1. The derivative of x with respect to x is just 1. So that's just a 1. This is dy dx. That's what I'm solving for. So I'm going to change that to a y prime, because y prime is just easier to work with when you're doing the algebra at the end. So now, so this is 4x y to the third plus 6x squared y prime. Okay, this just turned into the y prime. And then I'll put parentheses around that. And then this is cosine of 2x squared y to the third equals 9x squared. Now I've just got to solve for y prime. Now, you could divide both sides by cosine, and then you'd have to subtract that term and then divide by that term, and you'd end up with a very messy complex fraction. So I recommend that you first, if you're solving for y prime and it's in parentheses, I recommend first that you distribute what's being multiplied by the parentheses. So we would end up with 4x y to the third cosine 2x squared y to the third. And I'm going to leave the y prime at the end. Plus 6x squared y squared cosine 2xy y to the third y prime equals 9x squared. All right, so we just got the y prime in one location. We don't have to like factor it out and then divide both sides by a big parentheses. We just have to move this term by subtracting it from both sides, and then we'll divide both sides by that right there. So when I subtract both sides, that from both sides, I get 6x squared y squared cosine of 2x squared y to the third times y prime equals 9x squared minus 4xy to the third cosine of 2x squared y to the third. And then I'm very close to having this by itself, y prime. I just have to divide both sides by this. And I'm running out of room, so I'll go like that. So we've got y prime is equal to 9x squared minus 4xy to the third cosine of 2x squared y to the third all over 6x squared y squared cosine of 2x squared y to the third. Okay, that is it. Okay, now I'll just switch. dy dx is the same as y prime, so I'm just going to leave it like that. I think that's fine. All right, so that is the derivative of y, not in terms of x, but in terms of both x and y. So, yes, there's that. We're going to do another example because it takes seeing this a few times. All right, so I'll go a little bit faster. So, I'm finding dy dx. So I'm finding the derivative of y with respect to x. Y prime is another name for it. Y is right here. It is not solved for. It is mixed in with other variables. So I need to do implicit differentiation, which means that you set it up like this. Okay, you just take the derivative of every term with respect to x. I know it's going to be d dx because dx is in the denominator when they're, in dy dx in that notation. So this is equal to this. Often they don't put the parentheses. I like to add them in because it makes it to me more clear that natural log is a function and this is the input of it. Okay, now I'm going to hold off on these derivatives because they're super simple and straightforward, and I'm going to do this one first because it involves chain rule. Implicit differentiation always involves chain rule, but this is like a super chain rule because I've got to do chain rule anyway, even if it were not implicit differentiation. So 5xy squared is the inside, natural log of blank. Now to do the derivative of this, I need product rule. So d dx of 5x, and then you just bring down the y squared, plus bring down the 5x, d dx y squared. Okay, so that's going to be the derivative of the inside function. The derivative of the outside function, the derivative of natural log is just 1 over whatever's inside of it. So this blank went down there. I've got to put back in this blank what used to be there, which was the original inside. So 5xy squared. Okay, still not done. I'm bringing down, so this equals sign is coming down here. So the derivative of 5x is 5 times the derivative of x. And then I bring down the y squared plus bring down the 5x. The derivative of y squared is 2y times the derivative of y. All right, this is still in parentheses. And then this comes down. Guys, instead of bringing this down as 1 over 5xy squared, I'm just going to go like this. Because really, that whole thing is over 1. When you're multiplying fractions, you just multiply the numerators and you multiply the denominators. So we would end up with just one fraction like that. Okay, now I'm ready to do the derivative of this side, which was, they were pretty simple. So the derivative of 3x squared is 6x, and then implicit differentiation, so always times the derivative of the variable, plus 0. Now, you go through, if you see a dx, that is just a 1. The derivative of x with respect to x is just 1. So that's a 1. That's a 1. And then to make the algebra easier, the dy dx, I'm going to change to a y prime in the next line. So this is 6x equals 5y squared plus 10xy y prime all over 5x y squared. However you want to think of it, you could put that over 1. You could multiply both sides by 5xy squared, or you could, get common denominators and then cancel the denominators. I'm just going to cross multiply. Okay, so this is going to get multiplied up to the other side's numerator, and this 1 gets multiplied up there. So anyway, and I'm going to flip the equation. So I've got 5y squared plus 10xy y prime equals, I'll get 30x squared y squared, because I just multiplied 5xy times 6x. Now I'm solving for y prime, and good thing it's only in one location, so it's not like I have to get the y primes on one side and factor it out and all that. So I'm going to subtract 5y squared from both sides, and then I'll divide both sides by that. So I'm going to end up with 10xy y prime equals 30x squared y squared minus 5y squared. And then I end up with y prime. I guess never mind. Okay, so y prime equals 30x squared y squared minus 5y squared all over 10xy. And I know they asked us to find dy dx, but y prime is the same thing. Okay, guys, there you go. I'll see you soon. Bye-bye.